Students, welcome to Sunil's tutorial. I'm Sunil Milwani and today we'll be doing this chapter called as magnetism. Let's see some theory of magnetism. What do we understand by magnetic flux? Now, magnetic flux is defined as the number of magnetic lines of field or magnetic field lines passing through any surface area. Right? It is defined as the number of magnetic field lines it is defined as the number of magnetic field lines passing normally through the surface, right? It is denoted as phi. That's how it is denoted, right? Now let's assume that if delta S is the surface held normally, if delta S is the surface held normally and B is the magnetic field, is the induction, sorry. If B is the induction, then magnetic flux is given by the formula B into delta S. B vector dot delta S vector. Right? The units for magnetic flux. Units Webers. That's the units of magnetic flux. Right? Do we get this in clear? Next, magnetic induction. What do we understand by magnetic induction? I had already explained this to you. Magnetic induction is defined as the number of magnetic lines crossing per unit area. The difference between flux and induction is, in flux the number of lines through any area, in magnetic induction through unit area. Fine, do we get this in clear? Defined as the number of lines, number of magnetic lines of induction crossing per unit area normally through a magnetic substance. Fine. It is denoted as B, magnetic induction, right? Magnetic induction is also called as flux density, also known as flux density. Fine. The SI unit, Tesla. The SI unit for that is Tesla or Webers per meter square. That's my SI unit, right? Next, third, magnetic intensity. What do we understand by magnetic intensity? If magnetic field B0 exists in vacuum, if magnetic field B0 exists in vacuum, then I can say that the magnetic intensity is given by intensity H is nothing but B0 upon mu 0. Fine. Where mu 0 is the absolute permeability. Where mu 0 is absolute permeability. Fine. The value of mu 0 is nothing but 4 pi into 10 raised to minus 7 Tesla meter per ampere, or it is also Webers per ampere meter. Right? So that is magnetic intensity. It is the magnetic field in vacuum divided by the permeability. Right? Now, let's try to find out the units. I already gave you this. This is Webers. Let's find out the SI unit. The unit of magnetic intensity. The unit of magnetic intensity, unit of H is going to be nothing but magnetic field is Tesla. Mu 0 is nothing but Tesla meter per ampere. So Tesla gets cancelled, so this is going to be nothing but ampere per meter. Right? Okay, so that's my unit for magnetic intensity. Next, what do we understand by intensity of magnetization? Intensity of magnetization is defined as the magnetic moment acquired per unit volume. Intensity of magnetization is defined as the magnetic moment acquired per unit volume. A magnetic moment acquired per unit volume of a specimen when the specimen is kept in a magnetic field. Magnetic moment acquired per unit volume of a specimen when the specimen is subjected to a magnetic field. Unit I, it is denoted as I, right? How is it formula wise? Intensity of magnetization is magnetic moment per unit volume. That is going to be the formula for this. Unit of intensity of magnetization is magnetic moment, which is nothing but ampere meter square upon volume is meter cube. So this is going to be ampere per meter, right? So intensity of magnetization also has a unit of ampere per meter. Fine. Now let's consider that if A is the cross section area and 2L is the length of the magnet, if small a is cross section area and 2L is length of the magnet, then we know that volume is nothing but area into height. So area into 2L. We also know, guys, we also know that magnetic moment M is nothing but m into 2L, right? Therefore, I can say that intensity of magnetization, which is equal to m upon v, can be written as m into 2L upon a into 2L. So therefore, this can be written as m upon a. So intensity of magnetization is also defined as pole strength per unit area. Therefore, intensity of magnetization is also defined as pole strength per unit area, per unit cross section area. Fine, do we get this thing clear? Now, we know that magnetic induction is B. Now, magnetic induction is equal to the sum of magnetic field and that is magnetic field in vacuum plus the magnetic field produced on account of magnetization. I can say that magnetic induction is equal to sum of magnetic field B0 that is your magnetic field in vacuum and magnetic field produced on account of magnetization, of substance, right? Therefore, I can say B is equal to B0 plus mu 0 into I, magnetization of the substance. Now, B is equal to mu 0 can be written as mu H, we have already defined this, plus mu 0 I. Thus, I can say that B, magnetic induction, is nothing but mu 0 H plus I. So, the magnetic induction is nothing but the sum of magnetic intensity and the intensity of magnetization multiplied by permittivity. B, magnetic induction. Magnetic induction is also defined as the sum of the magnetic field produced in vacuum and the magnetic field produced on account of magnetization of the substance. So therefore B is magnetic field in vacuum and this is your magnetic field on account of magnetization of the substance, right, where it depends upon magnetic intensity, right. So in that case I could say that just substitute the value mu 0 H into mu 0 I, you will get your answer. Next, what do we understand by magnetic susceptibility? What is magnetic susceptibility? It is defined as the ratio of intensity of magnetization to magnetic intensity. Defined as the ratio of intensity of magnetization to magnetic intensity. Right? It is denoted as xm. So I can say xm is nothing but intensity of magnetization to magnetic intensity. Fine. Now what is magnetic susceptibility? It measures the aptness of the material to acquire magnetism. What is it actually? It measures the aptness of a substance for material to acquire magnetism. Fine. Now, since magnetic susceptibility is the ratio of two similar quantities, therefore it has no units. Right? Next, what do we mean by magnetic permeability? Magnetic permeability is defined as the ratio of magnetic induction to magnetic intensity. Defined as the ratio of magnetic induction to magnetic intensity. It is defined as the ratio of magnetic induction to magnetic intensity. And do we get this thing here? So I can therefore say that mu is equal to B upon H. Fine. Now, what does magnetic permeability actually do? It measures the conducting power of the passage of magnetic line. It tells you how many magnetic lines would actually pass through the substance. It tells you the ability of the magnetic material to allow magnetic lines of induction to pass through it. It represents the ability of magnetic material to allow magnetic lines of induction to pass through it. Right? So that is the actual meaning of magnetic permeability. Units. SI units. Now SI units will be nothing but the units of magnetic induction, that is Tesla, divided by the units of magnetic intensity. Magnetic intensity is nothing but ampere per meter. So therefore the units is Tesla meters per ampere. That is TM per ampere, right? That is going to be my unit of magnetic permeability. Now, we know that absolute permeability is denoted as mu 0, and we also know that mu 0 is nothing but 4 pi into 10 raised to minus 7 Tesla meters per ampere. Right? Now, I can say that also B is mu 0 H plus I. Divide this equation by H. So I'll get B upon H is nothing but mu 0 H upon H plus I upon H. I'm dividing both the sides. Now B upon H can be written as, but B upon H is nothing but your magnetic permeability, which is mu, and I upon H is nothing but magnetic susceptibility. Therefore I can say mu is equal to mu 0 1 plus xm. H upon H is 1. So that's your relationship between them. Therefore I can say that mu upon mu 0 is 1 plus xm. Right? Now let's assume that mu upon mu 0 is r. Be equal to mu r. Therefore I can say mu r relative permeability is nothing but 1 plus xm. So the relative permeability, where mu r is the relative permeability of the substance, and mu r is relative permeability of substance. Right? Do we get this in clear? Okay. We will stop this here for the day. Thank you very much.